Okay, we're going to graph a system of quadratic inequalities. And if it's a system, that means we have at least two. And so let's see. You can see, I think, that this first one is done in red or pink over here. You can see that it's going to go through plus 4, and it does. Right up here, it goes through at 4. And it opens down. You know that because it's negative. So it opens down. And you also know that y is less than or equal to. So you go to y, and you think to yourself, less than. That's underneath. And you shade in the stuff underneath. So they shaded underneath with pink or light red. Okay, and then the second graph they did in blue. And let's see. This one's not as straightforward because you'd have to factor it. So they factored it. It looks like they said x, we're going to say minus 3, and x plus 1. And so your two roots would be x equals 3 and x equals negative 1. So here's negative 1 right there. I don't know if you can see that. Let's try red again. Here's negative 1, and here's positive 3. Those are the roots. And you would say to yourself, let's see, 3. I said 1. I meant negative 1. I think I said negative 1. Negative 1. 3 and negative 1. If I add those together and divide by 2, that's the average, right? So that's 2 divided by 2. The average is 1. That's the axis of symmetry. That's the line that goes right down the middle. Okay, that's the axis of symmetry right there. X equals 1. And then I can plug in 1. I can say f of 1. What happens when I plug in 1? Well, let's see. I get 1 squared. And then I say minus 2 times 1. And then I say minus 3. So what happens? I get 1, minus 2, minus 3. That's equal to minus 4. So I'm down here at minus 4 on the axis of symmetry, on the dotted line at 1. And I'm down here at negative 4, negative 4. So they graphed it, and then you can see that because it says y is greater than but not equal to, it's a dotted line. You can see this dotted line along here. Okay, and you can also see that it says y is greater than, so we go to the vertex and we're like above. Greater than is above, so we start shading in the area above the vertex, which means everything on the inside. Okay, so that's what we do, and that's how we do it. We graph two parabola, and one of them is everything underneath, and the other is everything on top. So the purple, I guess you call that purple in between, is the solution. Anywhere in the purple field between the blue and the red, that's your solution. So now I'm going to show you this one. And actually I'm going to go down where I have a bigger graph. I think it's better down here. We'll see how it goes. So let's see. The first one, not too hard to graph because it's a very simple form. I know I'm going to start at negative 4. So I'm down here at negative 4. I know what a parabola does. It goes over 1 up 1, right? When I plug in 1 to x squared, I get 1, right? So I know this isn't 1, but if I were at 0 and went over 1, I'd go up 1. And then I'd go over 2. I shouldn't put a dot there. I'd go over 2, and I'd go up 4, because if I put in a 2, I get a 4, right? So, and then 3, I'd get a 9. 3 squared is 9, so 3 would be up here. All right, so that's what I would do if I were at 0. Well, the same thing happens even though I'm down here at negative 4. Same thing still happens. So I go over 2 and I go up 4. 1, 2, 3, 4. I go over 3. I go up 9. So let's see. 4 plus 5 is 9. So I'm up here at 5. And then it's symmetrical, so the same thing happens on the other side. 1. The y-axis is the axis of symmetry. It's right down the middle. So then I should also have a point over here, and if I go over to the other side of this point up here, and let's see, this is greater than or equal to, so I'm going to connect these dots. I don't have to use a dashed line because it's greater than or equal to. And I will shade that after a while. But first, I want to do this other one. And this one's not as easy. So I'm going to do the ACB method. Okay, the ACB method says multiply A times C. So that's negative 2 times 4. And I get negative 8. Okay. So I would like to get two factors of negative 8 that add up to positive 7. Okay, so let's see. Factors of 8. Well, I have, it's supposed to be negative 8 and it's supposed to be positive 7. So I'm going to have 8 times negative 1. Those are factors of 8. And if I add them together, I get 7, right? If I say 8 plus a minus 1, I get 7. Okay, so let me rewrite this. I'll say negative 2x squared. That doesn't change. But the middle term changes. It changes to plus 8x minus x. And then I write the plus 4. Okay, so notice a couple things. The negative 2x squared and the 4, they didn't change at all. Okay, they're still the same. But the middle term turned into two pieces. Okay, how did I know which pieces to use? Well, I found them over here, 8 and negative 1. Okay, so I just want to make that as clear as I can. I rewrote the form, but I rewrote the equation, but it's still the same thing. Mathematically, it's still the same thing. And then I look at this and I say, what can I factor out of both of these two? This is why we practice factoring the greatest common factor out. So the greatest common factor in this situation, I'm going to take out a negative 2x. Okay, if I factor out a negative 2x, the only thing left behind is an x. I factored out a negative, so this positive becomes negative. And let's see. The 2 comes out of the 8, and I get 4. The x is gone, so I get x minus 4. All right. And then on the second part, I'm going to factor out a negative again. I'm going to factor out a negative 1. Well, 1 or just a negative. That leaves me with x minus 4. And if I did my job right, the inside is the same for both of them. Okay? And that's great. So what we're going to have here is we know one of our factors is x minus 4 because it showed up in both places. Okay, the other factor that we have is going to be the leftovers, this and this. Okay, and so we're going to say they're both negative, which is kind of weird, but that's fine. And we know that really the negative goes out in front, so we could take that one negative and put it out in front. We could say x minus 4, and then 2x plus 1. Or we could leave it the same. I just would rather have positives in there. Notice that I didn't change the first part. X minus 4 is unchanged. The one negative part I took out front. So however you want to do it. But now that we factored it, and by the way, if you FOIL this, you will find that it's the same. X times x, 2x is 2x squared, negative 2x squared. There's a negative out in front to take care of the negative. And then if you do the outside, we have 1x, and the inside is negative 8x, and that is 7x, right? And there's our 7x up there, right there. That's our 7x. So we do get back to the same place. And as we continue to FOIL, as we continue to FOIL, we do the last negative 4 times 1. And you say, that's a negative 4. Yeah, but again, we're taking care of it with the negative out in front, so it's positive 4. Okay, so if we FOIL it to check our work, we get the same exact thing. And the benefit of this now is that it lets us know what the zeros are. X is equal to 4. If x is equal to 4, this first term is 0. So x equals 4 is one of my solutions. And then you say 2x, when is that equal to 0? Well, you can either spot it, or you can set it equal to 0 and solve. So we'll say 2x is equal to negative 1, and we'll divide by 2. We'll say x is equal to negative 1/2. And we look back up there and we say, is that true? 2 times a negative 1/2? If I put that in right here, I'll get negative 1, won't I? And negative 1 plus 1, that will be 0, so I'm good. Okay. All right, so that tells me the two places where I'm going to go through. I'm going to go through at x right there, x equals 4, and I'm also going through at minus 1/2. Okay, I want the average of these because I want the axis of symmetry. So I'm going to say 4 minus 1/2, and I want the average, so I'm going to divide by 2, so I'm going to multiply by 1/2. Okay, you say, well, I don't like the look of that because that's fractions. Well, okay, I understand. We say 8 over 2 is the same thing as 4. We get a common denominator of 2. Just to be clear, I have 4 over 1. I multiplied the top and the bottom by 2. Okay, so I have 8 over 2. Take away 1 over 2, that's 7 over 2. I have this 1/2 out here because remember, when I find the average, I have to divide by 2 to get the average. And that's 7 over 4. Okay, so 7 over 4, for purposes of graphing, is almost 2, right? It's almost 2. So let's look here. Here's almost 2. Right here is almost 2. You know, it's hard to tell when I'm graphing exactly where this is, but I'm doing the best I can. And hopefully this dotted line looks like it's going right down between the two red dots. Okay? Last thing is, where on this dotted line am I? And so I need to remember, what's the formula? Well, I could go back up here and look at the formula. Where's the formula? Here's the formula up here. There's the formula. I could feed it into that. But you know what? I have a nice factored version down here. I think I'm going to feed it into this nice factored version right down there. So let me feed it into that. My answer is 7 over 4. That doesn't seem particularly attractive. But I have negative 7 over 4 instead of x minus 4 times 2x plus 1. Oh wait, I forgot to substitute for x. Sorry about that. We have 7 over 4. And we're adding 1. Okay, so I'm using this formula up here, which is the same. Hopefully it's the same formula as this right here. It is the same. I factored it. I just think it's easier if I put it in the factored version. So let's see what happens here. I'm going to say minus 7 over 4. Let's see, the result is negative. So then I want a common denominator, right? I have 4 over 1. I multiply the top and the bottom by 4. I get 16 over 4. And I have 2 times 7. That's 14 over 4. And then I'm adding, and I need a common denominator. The 1 turns into 4 over 4. 4 over 4 is 1, right? And it's a common denominator. So let's see. I have 7 take away 16. That's a negative 9 over 4. And by the way, it's negative out in front, so the negative is going to go away. And let's see, over here I have 18. Oh, yeah, and good. Okay, so let's see what happens here. 18 and 9. 18 times 9. What is that? 18 times 9. That's 162. 162. And it's positive because I have 2 negatives. And 4 times 4 is 16. Well, you know, at this point, you know what that's almost equal to? What's 160 divided by 16? That's almost equal to 10. So I'm just going to go ahead and say it's about 10. If I did it on my calculator, you know, divided by 16, I'd get 10.125. Do I really care about the 0.125? Not so much. So I go to my dotted line and I put a dot at 10. Plus 10. And I say, oh yeah, it is true that I'm opening, oh wait, not there. I'm opening down because of that negative sign, right? So I kind of I should have expected that I'd have a vertex up in the air and I'd be opening down. And I am doing that. So let's see here. I can just go ahead and sketch this in. This is also less than or equal to, so I don't have to worry about a dotted line. You know, the one thing I'd kind of look at, if x is equal to 0, where's this thing going to hit? It's going to hit at 4. So that'll help me hit in the right place. I know it's going through the red dot. Okay. And then on the other side, just do the best I can. It's going to hit there. Okay. So, the first one is greater than. So I go to this vertex and I go above. And I start filling in everything above. I shade everything above the purple line because it's y is greater than. Y is greater than. For the second one, y is less than. So I go to the vertex, here's the vertex, and I shade less than underneath. So I start shading everything underneath. And it's going to have a little overlap that looks green. And that's going to be my result. So I know this is pretty long, but it was a good review for the things we have just done. And we could always use the review for the old stuff. All right, so the shade of green is the overlapping area, and there you go. That's the solution. So just said graph the system, and we're interested in where they overlap. So there we go. That's it. I know that's extensive. That's the longest kind of problem that we do. I know. We've been doing it for a while though now, so hopefully you're getting better and better at it.